Hi everyone, Ashton here from iCanMed, and welcome. In this video we are going to go through strategies for abstract reasoning. Now, abstract reasoning is definitely one of the more perplexing question types in UCAT, especially at the beginning. And that's because a lot of the people, you just never seen these types of questions before. It's like, what is this? It's just a whole bunch of patterns, abstract shapes, and you have to try and, recognize some sort of coherent sequence that's going on in each of the questions. Okay, so with previous question types, at least there was a lot of English things that we can read and try and understand ourselves. But here, very little, well, no English, and it's just all these patterns, and it's a very, very foreign, very new thing. So at the beginning, people are very scared of abstract reasoning. Okay, but after a while, after getting familiar with these techniques and being more familiar with the question type, you should realize that it's not so scary anymore. And the more questions you do, especially after using our techniques, the more familiar all the abstract patterns become and things start falling into place. So hopefully with the techniques that we show you today, you are able to bring that home and build on it in order to conquer abstract reasoning. Okay, now abstract reasoning has three different question types, but we'll look at the first question type, which is the sets question type. It is actually the most dominant question type in abstract reasoning. There are 55 questions. Yes, that's right, 55 questions in only just 13 minutes. And you might think that's impossible. How do we do it? But the students last year that we had, abstract reasoning had a lot of people scoring full marks as well. So with abstract reasoning sets question type, it actually consists of 50 of the 55 questions. And that's what we're going to go through today, the sets question type. So if you can master this question type, you will be able to get 50 out of the 55 questions correct. So that's more than 90% raw in section 4 abstract reasoning. Okay, and this will be more than enough to get 99th percentile. Okay, so let's take a look and pay attention to the strategies used for abstract reasoning sets question type. Okay, so what is the sets questions type? Okay, down here you can see that the sets question type consists of two sets, always. Okay, it will consist of set A and set B. So with set A and set B, both of these sets will have 6 boxes. And the 6 boxes are independent of one another and have a pattern inside of each box. Okay, so this means if I was to take a pair of scissors and cut up my boxes and rearrange them in any order, the pattern will still exist. So please do not try to look for some sort of zigzagging pattern or some sort of like round pattern going from 1, 2, 3, 4, 5, 6 like this, because that is not how the pattern works. The pattern is always inside and within each box, which is why you can just cut out the boxes and put it in a straight line and the pattern will still make sense because you do not check between each box. The pattern is always independent inside each of the boxes. Okay, now the reason why you're given 2 sets is because there will be one pattern for set A and there will be one pattern for set B. And they will be quite similar, but ultimately at the end of the day, they have to be different patterns. So you have to have a set of patterns for set A, which will distinguish itself from the set of patterns in set B. They cannot be exactly the same. There has to be some sort of difference to distinguish the 2 sets. Okay, now this also makes it sometimes easier to find your patterns, because when you find your pattern for set A, sometimes the pattern for set B could be almost the direct opposite pattern of what you found in set A, and vice versa. Okay, so sometimes set B is easy to find. Then you take a look at a set A and try and find and see some sort of similar pattern there. Okay, so that's probably the easy part. Okay, now the harder part is actually finding these patterns, and we'll go through that systematic check very shortly. Okay, now this here at the bottom. Okay, so this here at the bottom is how they ask questions for abstract reasoning. Okay, this is just one of the ways that they ask questions, where they give you, okay, one image and they ask you, does this belong in set A, set B, or neither? Okay, but in order to do this question, we need to know the pattern for set A and set B. Okay, so once we know the pattern for set A and set B, then answering the question becomes very, very trivial. Okay, so the hardest part is actually finding the actual pattern. So I'm going to quickly introduce to you all the available patterns in UCAT. Okay, and this is extremely, extremely valuable. So make sure you take your notes. Now, the first thing to take note before I jump into the possible patterns for UCAT is, first of all, abstract reasoning are things that is abstract. But what does that actually mean? Okay, of course it means things that are not in English. Okay, but in the case for UCAT, when you are looking at abstract features, okay, there are certain things that you need to focus on. So these are all the abstract features that UCAT uses when determining a pattern. Okay, so here we go. I'm going to list it down right here. Okay, now the first thing you take a look at is what you can see in front of you right now. What do you see? Oh, you see different shapes. Okay, so UCAT likes to use shapes as a feature. Okay, now another thing they might use is color. This question does not have any color examples, but color, you can imagine, sometimes maybe you have the triangle being shaded in black. Sometimes it might be striped, or sometimes it might be polka dot. That's when UCAT uses color as a feature. Okay. The third feature is rotation. Okay, so you might have the same shape in your boxes. However, you might see that the shape is rotating. Okay, so UCAT will use that rotation to form some sort of pattern. So you need to be very wary of that. Okay, and now the fourth feature, which won't make much sense now, but I'll list it down first, is position. Okay, so position is actually, the box has, 4 sides, and sometimes your pattern might be, maybe the triangle is always in the top left. Okay, maybe the triangle is always in the bottom right. Okay, so it uses position as some sort of pattern as well. Okay, so these are the 4 abstract features that you can actually see that you can actually see and use in order to find a pattern. Of course, later on, you'll see that there are a bit more features, but I first need to talk about the different patterns. Okay, so these are the things that you can literally see in front of you. So how did UCAT take these features and put them together to form some sort of pattern? Now, there are 3 major patterns in the UCAT, and I'll list it in here for you to see. Okay, now these patterns are position pattern, which is also very similar to a feature. Remember when I said a feature is literally just, a position pattern is literally just if like a certain shape is in a certain place. Okay, so that is a position pattern. Now the second pattern we call a matching pattern. So matching is when you grab 2 features and form some sort of rule between those two features. Okay, now for example, I might grab a shape and a color, and I might be, oh yeah, the rule is that the circle is always black. Yeah, so the shape, the circle, is always a certain color, which is black, and that's for set A. And for set B, the rule might be, oh, the circle is always polka dots. So it has a different shape and color rule. Okay, so that is a matching pattern. You can grab any of these two features and form some sort of rule between them, and there you have a matching pattern. Okay, now the third pattern is a counting pattern. Okay, so your counting pattern is anything possible that you can count. So what are the things you can count? You can count shapes, different shapes, yes. You can count different color. You can't really count rotation or position though, but you can count shapes and color. Now there are other features you can count as well. If you break it down, you can also count things like edges, okay, intersections. Okay, you can count areas as well. So anything that you see that you can count, you can count. Okay, you can count corners. And then that counting may also form a pattern. Like for example, in set A, there's always 4 corners in my shape in set A. And set B, there's always 5 corners or edges or intersections in set B. Okay, so that is that pattern, counting pattern. Okay, so here are all the possible patterns. Now do take note, there is a more complicated one, which is matching and counting as well. Okay, so that's when, so if I put 4 here, you're forming some sort of rule with your counting. Okay, so your counting has some sort of special rule. Okay, like for example, if there is a circle in set A, there will always be 3 triangles. Okay, and in set B, whenever there's a circle, there is only 2 triangles. Okay, so that's when you have to use counting as part of your rules, in your matching rules. Okay, so that's a lot of patterns that you can see, but literally that's it. These are all your possible patterns in the UCAT. Like I said at the beginning, it's quite overwhelming and people think, oh man, there's just so much to learn. But that's essentially all there is to it in the UCAT. So you need to just get more familiar with these patterns and these features. Okay, now iCanMed course has a lot more tools to help you get more familiar with these features and patterns. Okay, such as the glossary, solutions review worksheet, the checklist. Okay, but these are tools that we just don't have time to go through in this quick video. Okay, but essentially you're just slowly getting more and more familiar with all these abstract features and how these features connect together in these major patterns. Okay, now how does that actually help me in answering the question? Now, you take a look at this sets that we have in front of you. So you have what features? Okay, the shape, color, rotation, and position. Except for this particular question, there are no colors. Okay, so you don't focus on any colors. There are no rotation, so don't focus on any rotation for this particular question. So you only need to focus on 2 things, the shapes and the position. Okay, so shapes and position, that's great. I've eliminated color and rotation because it can't possibly exist in these sets. There's no rotation, there's no color. Now I take the shapes and position and I try to find certain patterns. Remember, there's a position pattern, matching pattern, counting pattern. So position pattern is there something in the same place in set A and set B? Okay, and now you only have shapes. So then you ask yourself, is there the same shape in the same position? Okay, and then you take a look and you realize, no, there's no shape that's in the same position. Of course, you look at one set at a time, and you just zoom out and you realize nothing is in the same place all the time. Okay, so it's not a position pattern. Now, another thing you notice when you're checking for that position pattern is that when you look at each of your boxes and you're trying to track, whether your shapes are in the same place or not, you'll also notice that each of your boxes have the same shapes inside of them, just in a different place. Okay, so that's for set A. Now, set B is the same as well. And in fact, if you look at set A and set B, they have the same shapes, and the only difference is they're in a different position. So there cannot be any possible counting patterns whatsoever, because you have the same count for everything in set A and everything in set B. Okay, no matter what you count, it will always be the same because you have the same shapes in every box. So that means all that's left is a matching pattern. Okay, you can't have counting, and of course you can't have matching and counting, because whatever you count will always be the same in set A and set B. You won't get different rules to separate set A and set B. Okay, so the only thing to separate set A and set B is the matching pattern. And remember, with matching, you're just finding rules between two different features. What features do we have? We only have shape, we only have position. So when I take a look at my shapes and position, am I able to form some sort of rules? Okay, now one of the harder things about sets questions is that there are distractors. So not everything actually forms a pattern. You are only able to form a pattern with the features that actually form a pattern. And all the other features are just distractors. But we don't know which shape is a distractor. Is the triangle a distractor? We don't know. Is a square a distractor? We don't know. So what you have to do is you have to check each of your shapes to see if there is a pattern with their position or not. Okay, now there's only 6 shapes. So literally you're only testing 6 things, which doesn't take too long. Okay, now you are given the triangle and you take a look at the position of the triangle to try and form some sort of pattern that you can see. And you can see that, well, there's no real solid pattern for the triangle. It can be top left, top middle, okay, bottom left, bottom middle, okay, and then you realize there's not much of a pattern there, nothing cohesive that I can see. Okay, then next you look at the squares. Okay, so the squares, is that top middle, top left, top right, top middle, top left, top right, and if you noticed, the pattern that I kept repeating was always top. The square was always on the top. That is a pattern. Okay, so that is one thing that you check and you realize, hey, for set A, the square at the top seems to be something that's always, a consistent pattern for set A. So that is one of my rules. Okay, then you check for the rest of the shapes as well. Okay, pentagon, top right, bottom left. Okay, bottom middle, top left, bottom left, top middle. Nothing that's really cohesive. Okay, nothing that's in common. Okay, so then you check and you just have to systematically check each of your shapes. Okay, there is no other way to actually do the question but in a systematic way. Okay, so I look at the bottom right, which is the circle, and you go, circles at the bottom right, top right, top right, bottom right, top right. What's in common? It's always on the right. So that's the same word I repeated for all of those 6 boxes, that the circle was always to the right. So that is a common rule. My circle was always to the right. Okay, then next you check the in the hexagon, okay, bottom middle, bottom middle, bottom middle, okay, oh, bottom right, oh, it's always at the bottom. No, it's not. Top middle, top middle. So nope, it's not always at the bottom, so that's not the pattern there. And the last thing, the diamond, bottom left, bottom right, oh, then top, middle, bottom, no pattern. It can be top, bottom, left, right, middle. It doesn't seem to be a pattern there for my diamond. So there we go. It seems that I only have 2 features that form the pattern, and the rest are just distractors, and it doesn't form any cohesive pattern. So that's my pattern for set A. As you can see, this is a very systematic way of checking the pattern, but of course you wouldn't know to check for the patterns if you didn't know about this shape and position as being a feature. Okay, so this is to make you more aware of what shape and position actually means and how they can match together as a pattern. Now you do the same for set B. So set B will have a very similar rule to set A. So similar as in it should be also a matching shape and position pattern as well. Okay, it will always be the case. However, it will not be the exact same pattern. It will be slightly different. Okay, so now I need to just check all of my shapes with set B as well. So you check the triangles and you realize, nope, it could be top, bottom, left, or right. So that's not it. Hexagon, okay, is at the top, it's at the bottom, right, left, middle. So that's not my pattern. The square, top, bottom, left, right, middle, doesn't help me as well. Okay, so these 3 shapes, all distractors. Pentagon, it's to the right, bottom middle, okay, bottom left, bottom right, bottom left. Oh, it was always at the bottom. Okay, so the pentagon was always at the bottom row. Okay, so I'll just highlight that to make it easier for you to see. So there we go for the pentagon. Okay, now the next one, circle. Okay, circle is at middle, bottom, bottom, middle. Okay, top, middle, top, middle, top, middle, bottom, middle, bottom, middle. What's in common? Always in the middle. So there's our pattern for the circles. Okay, and of course you're left off with the last shape, which is the diamond. And as you can see, there probably isn't going to be a pattern for the diamond because it's at the bottom right, top right, bottom left, top right. That's already like the complete opposite. So there's no pattern there. The middle, bottom, top left. So no coherent pattern whatsoever. So there we have the rules. Okay, so it's a matching pattern. You're matching a shape with a position. Okay, and then you're just applying the 2 rules for set A and set B. So that's the hard part. The hard part is finding this pattern. So it's very important that you saw that system that I used to find it. So I'll do a quick overview. Okay, you make sure you identify the features that are inside your set. So here I realize, okay, there's this shape and this position. And then you go through the possible patterns. Okay, there was nothing in the same position. I couldn't have any counting because all my shapes are the same, all the counts would be the same. So I can only match my features with some sort of rule. Okay, what was my features? Shape and position. So let's start matching the shape and the position. And I found that there were patterns for these shapes and the rest were distractors. Okay, so you have to just systematically check each of your shapes with their position. And that is the sure way, the 100% way to always find the pattern for any question. Okay, now of course, different questions will have different features and will use different patterns. But like I said before, these are literally all the features and all the patterns in UCAT. Okay, so it's a huge boost, kickstart to your abstract reasoning by having just this information you have in front of you. So I hope you find it very valuable because it is extremely valuable. That helps you cut down a lot of time in your abstract reasoning preparation. Okay, let's finish off the question, which is just trivial now because you have the pattern. So when you say, does this belong into set A or set B or neither? You take a look at the positions. So for set A, squares always at the top, circles to the right. Oh, that seems to be the case. Square at the top, circles to the right. So it should belong to set A. Okay, just to double check, it doesn't belong in set B, and it doesn't because, okay, the pentagon is at the top when it should be at the bottom. Okay, so this definitely does not belong in set B, so it has to belong in set A. And for this question down here below, so like what we did at the top, just apply the same rules for set A and set B. Okay, when the square is at the top, okay, it belongs to set A, but also the circle has to be at the bottom, has to be at the right. But here it's at the bottom left, it's not at the right. So this does not belong in set A. Okay, does it belong in set B? Okay, when the pentagon has to be at the bottom. But if I look at my test shape, my pentagon is at the top, so it can't be in set B. So for this test shape, it can't be in set A, it can't be in set B, so it must mean that it belongs to neither. This list of features and patterns is extremely valuable. It will cut down your preparation time by a lot. Now we still have a lot of other tools to help us get more familiar with these features and patterns. Okay, solutions review worksheet, okay, the glossary and the checklist. Okay, but we've run out of time in today's video. If you found this video valuable enough already, make sure you check us out in future videos as we dive deeper into other question types and maybe this same question type as well in the future. So I look forward to seeing you all next time. And until then, make sure you use this precious information in beginning your abstract reasoning preparation.